experiment is for gravitational acceleration of a car. Some of the physics concepts for motion on a ramp are acceleration, a vector quantity that is defined as the rate at which an object changes its velocity, velocity, which is a vector quantity that refers to the rate at which an object changes its position, motion, the phenomenon in which an object changes its position with respect to time, gravity, the universal force of attraction acting between all matter, and force, normal force, friction, and weight. In this diagram, you can see how normal force, friction, and weight are acting on the object as it's going down the incline. In this video, it shows the regular ramp with the 6.096 height and the 11.684 height. Again, the oiled ramp at both heights, and then the dirt ramp at the 6.096 height, and then the 11.684 centimeter height. Experiment. And in order to create this experiment, we got stones stacked up to two varying heights, one being 11.684 and the other one being 6.096 centimeters tall. We got a 48.26 centimeter long cardboard that we had a frictionless one with regular cardboard, an oiled one, and a dirt one that we sent the car down to test out the varying accelerations and speeds at which the car goes down at different types of friction on a cardboard. In doing so, we also used a calculation to find the angle, the 14.01, using our 90-degree angle starting off and the hypotenuse and the height of our ramp. Here we drew in the vectors that are represented in our experiment. The velocity vectors point in the direction of motion downhill and parallel to the ramp surface. The object has a free fall acceleration straight down, and the object also has a vector that is parallel to the incline and a vector that is perpendicular to the incline. We know that acceleration vector of free fall equals the acceleration vector for parallel incline plus the acceleration vector for perpendicular incline. The magnitude of acceleration vector free fall is gravity, which is the hypotenuse of the right triangle. So here's the calculations that I mentioned previously. The first one is for the 6.096 centimeter height using that hypotenuse. And therefore we found the degree angle, which was 7.26. And that led us to find the acceleration, the theoretical acceleration, which is 1.238. And then in this calculation again for the 11.684 height, we found the angle to be 14.01 and the acceleration to be 2.37 meters per second squared. So right here is the experimental values we found for the regular cardboard at the 6.096 height. The acceleration was 1.207, and at the 11.684 height, it was 2.331. And both of those showed, the lower height showed a 2.5% error, and the taller height showed a 3.15% error, along with our times that it took for each trial. And then for the oiled cardboard at the 6.096 height, it was an acceleration of 1.136. And then at the 11.684 height, there was an acceleration of 2.258. And the percent error for the lower height is 8.24. And for the taller height is 9.05. For the dirt cardboard at the 6.096 height, the acceleration was 1.053. And for the 11.684 height, the acceleration was 2.177. And therefore, the percent error was 14.9 for the lower height and 15.6 for the taller height. As you can see, the percent error showed that with the oiled and the dirt cardboard, the more friction added, the more percent error there was, which is to be expected when your theoretical is calculated based off a frictionless slope. So that showed relative accurateness for our experiment and concluded that our hypothesis was overall correct. The objective of this experiment was to better understand how friction and resistance play a vital role in an object's motion, which, as we discussed, it did. This was concluded by measuring the friction of various resistance applied on the ramp when performed on a toy car at a slowly increasing speed. In conclusion, the data gathered in the experiment provide an overall understanding of how acceleration is directly impacted by the angle of a ramp when compared against various frictions. Ultimately, the car The experiment solidified the application of Newton's second law, stating that the acceleration of an object in motion is directly proportional to the net force acting on the object and inversely proportional to the object's mass. Thank you so much for watching.